What is up, guys? Welcome to the 23rd tutorial in our Python language basics. Here we're going to start the final topic, which will be classes and objects. As per usual, we'll start by spending some time in the slides. We'll start by talking about what are objects, following with what are classes, and then how do we use classes and objects in our code. We also have a couple more things to talk about, such as inheritance and static variables and functions. Now I figure I would talk about all of these at once in the slides rather than break it into different parts, just because they are all kind of related into one. Of course, when we turn to the code, we will divide these into their own sections. Now there will be quite a lot of information in the slides all at once, but a lot of it will actually be kind of recap from what we've learned in the previous lessons, which is why I thought it was okay to throw it all in at once. Now, if at any point in time you're feeling kind of overwhelmed or that you're just not absorbing any more information, it'd be a good idea to pause the video, make sure you're okay with everything, and then move forwards once you're ready. For starters, we'll talk about what are objects. It's important that we understand what these are before going into the other parts. Objects are just entities in our code with state or properties and behavior. Now that doesn't really mean a whole lot to us, but think about state as being a mix of all of the values of an object that kind of describe the object, and then behavior being typically to modify the state in some way. Now, I've been using the example of games throughout our tutorial series, and I think that's really relevant now. Think about, for example, a character within a video game. Well, a character will have various state, various properties or attributes, okay? These will all be represented with variables. They might have an X position or a Y position. They might have a certain amount of health, an inventory full of items, etc. And a lot of the functionality of that that character would be to modify the state, such as moving about. That would be changing the X and Y positions, picking up items. That would be modifying the inventory, maybe taking damage. That would be modifying health. Okay, so in this way, the state kind of describes the object, and the behavior is typically used to modify the state in some way. These are supposed to be modeled after real-life objects, so if there's something that couldn't possibly exist, that might not necessarily be a great place to represent it in code. Try to keep things as being kind of like real-life models where possible. Classes, on the other hand, are going to be implementations of objects. So this is not so different from implementing a function, that would be the class, and then executing a function, that would be the object. The implementation is there to specify basically how the object should run, but the object itself is doing the actual running. The state within a class is represented with variables. When variables belong to a class rather than just being global or in some random function, we tend to call them fields. So we'll be using variable and field interchangeably here. Behavior is represented through functions. When they belong to a class, these are called methods, and are again typically used to modify the state of an object, so they'll be used to change the variable values, etc. There is also a special initializer function that exists within classes to help set up the initial state, that is, set up the initial variable values. For example, if you were to spawn a video game character, then you'd probably want to assign a specific position, maybe a certain health value, maybe they'll have a name or something like that. We'd use the initializer to set up basically the initial values. We can also use our initializer to create instances of classes, and these are going to be objects. So if classes are the blueprints, objects are the actual items that adhere to the outlines described in the classes. Then how do we use these classes and objects together in our code? Well, like I said, class simply acts as a blueprint for an object. Again, it's just going to be there to tell the compiler that every single object of this type will have these variables, okay, and will be able to perform these functions. We use the initializer again to create instances of these classes, which are going to be called objects, and an object's initial state is set upon what's called instantiation. So when we initialize a class, it's called instantiation. I know that's a lot of different words and they might sound a bit funky, but that's essentially what we're doing. We're just creating what's called an instance of the object, which is basically just using that class to create an object. We can then use the object, once it's been created, to access the field or execute methods. So once we have an object, depending on the access level, but we're not going to get too deep into that, we will be able to get values and change values based on these methods that we've implemented. For example, again, coming back to a video game character, we would probably have, let's say, a move method or a move function that would be, again, used to modify the X and Y values or even the Z values of that character. So then what is inheritance? Sometimes classes need to provide very similar implementations, but there'll be some differences between them. There'll be some unique fields or methods. Now, if two things are very similar in code, we may end up with very similar implementations. And where possible, we want to try to not repeat code. Okay, write the code once, and then we can use inheritance to kind of avoid having to rewrite it. When several classes, or it could just be two classes, are going to be quite similar, we can probably use inheritance. So what that means is that one class can basically inherit everything from another class, but also add its own stuff. Again, coming back to a video game character, a non-player character will have pretty much all of the same behaviors and attributes that a player character would have, or would have quite a lot of the same behaviors and characteristics. However, a player character would have probably additional stuff, because of course a player character is going to be smarter. There'll be stuff that they can do that a non-player character cannot. Maybe a player character would have an inventory, but a non-player character wouldn't, and so on and so forth. Okay, so basically we would design the same system for both, but then the player character would have extra stuff. So that would be a good place to use inheritance. A subclass will inherit from a superclass. So in this particular instance, the player character would be the subclass, which inherits everything from the non-player character superclass. Now, sometimes we can what's called override a superclass implementation of a variable or function to provide a new one. For example, let's say a non-player character can only move left or right. Well, our player character will also want to move left or right, but they also might want to be able to jump. Might want to be able to move up or down as well. Okay, so generally speaking, a superclass will be a more generic implementation. So it will have stuff that is not very specific, whereas a subclass, which is inheriting from a superclass, will gain everything, but then implement its own stuff as well. So that means it gets more specific, it has more behaviors, probably more properties, and so on and so forth. Now, the final thing I want to talk about quickly are going to be static members. We won't spend a ton of time talking about static members, but I think it's important to note, important to talk about them because they are very useful. Static variables and functions essentially belong to a whole class rather than just an instance. What this means is that they hold the values across all instances of the class. Now, this is quite different from if we were just to, let's say, create a bunch of non-player characters, because as the game progresses, they would each have their own unique positions, health bars, because some might take damage, some might not. They might have their own unique names. Maybe some of them look and function very slightly differently, but they'll basically have all of these values set up initially to be the same, but they'll change over time. However, with static members, static variables and functions, these operate across all instances of the class. So they'll be basically the same for all of the player characters or non-player characters here. We actually don't have to create an instance to get access to a static member, such as a static variable or function. That's different from the stuff that we covered previously in the slides, because basically when you create an instance of an object, then you get to access the values within it. Well, with static members, we never have to create an instance because the static property or the function belongs to the class itself rather than just to an instance of an object. Static functions follow a pretty similar concept to static variables. If regular methods are going to be used to modify fields, then static functions are just used to modify static variables. Okay, so I know that was a lot to take in. Don't worry, there's no more than that in the slides. I would highly recommend you take a second to just kind of pause and reflect over all of this stuff. Maybe go back and watch it again if you need to, but that is basically all we're going to be covering with classes and objects. Don't worry, we will devote several of the next code sections to exploring each of these topics. I think probably we'll do 1 or 2 for classes and objects. We'll have 1 for inheritance, 1 for static members, so we'll be able to explore each of those concepts in greater detail. There's just a few key takeaways here. So a class will provide the implementation of an object. So that is kind of what variables an object should have and what behaviors it should be able to execute. Okay. Then the object itself is able to keep track of its values or its state, and it will be able to execute these behaviors through methods. We can use inheritance to basically have one class inherit or take away everything from another class, but also add additional stuff. The main purpose of that is to avoid having to rewrite code, and it just makes things easier to maintain. Static variables are going to be used across all classes. They're going to be the same across every instance of a class and are going to be very useful when we don't want to create an instance of a class to access a variable. Static methods are just going to be used to modify static variables. Okay, so again, give yourselves a moment, and when you are ready to move on, we'll start by just exploring the basics of classes and objects in the code. So stay tuned for that. Thanks for watching. See you guys in the next one.